Welcome to Spring LIB.
Hi everyone, so what we have today is a problem where a motorcyclist is going over a hill. We know the mass of the motorcycle is 200 kilograms. The contour of the hill is given by r equal to 5 theta. So at the instant in question, we know theta is equal to 5/3 pi radians, theta dot is 0.4 radians per second, and theta double dot is 0.8 radians per second squared. And what we're asked to solve for are the normal and frictional forces at this moment in time. And the way that we're going to be doing this is that we're going to be using our knowledge of normal and tangential motion and combining that with Newton's second laws, namely F equals ma, and solving for these forces at this moment in time. So the first thing we're going to do is we're going to solve for theta. So we know that theta is equal to 5/3 pi, and our theta dot is 0.4 and our theta double dot is 0.8. We know that r is equal to 5 theta, so therefore our r is equal to 26.18. R dot is just going to be 5 theta dot, and this is equal to 2, and our double dot is equal to 5 theta double dot, which is equal to 4. Therefore, we can use these pieces of information to solve for acceleration in the radial and theta directions. So AR we know to be equal to r double dot minus r theta dot squared, which is equal to minus 0.188. And our acceleration in the theta direction is equal to r theta double dot plus 2 r dot theta dot, which is equal to 22.54. Next, what we're going to do is that we are going to define an angle psi, and this angle psi is the angle between the tangent vector at that radius and basically the tangent vector to that curve. So basically what this looks like is we have our point that our curve is centered around, and here is the hill. This is our r, and here's our tangent vector. And this here is our angle psi. So we're going to use that because that's going to help us resolving our forces in the radial and theta directions. So to quantify psi, we say that tangent of psi is equal to r over dr d theta. And by using the quantities that we know, we see that tan theta is equal to 5.236. This yields us a psi that's equal to 79.2 degrees. Next, let's go ahead and draw a free body diagram. So here are our directions of acceleration, r and theta. We have our weight force acting down through the center of mass. We have a normal force that is coming from the hill, and we have the frictional force. This here is our angle psi, and using that knowledge, we know that this angle here is equal to 10.81 degrees. So what we're going to do is we're going to take Newton's second law in the radial direction. So we see that net force in the radial direction is equal to m times ar. This gives us that F sine of 10.81 minus n cosine 10.81 plus 209.81 times cosine 30 is equal to MAR. And then if we take Newton's second law in the theta direction, so theta is equal to MA theta, we see that this gives us F cos 10.81 minus 209.81 sine 30 plus n sine 10.81 is equal to MA theta. Solving both of these equations, since we have two unknowns, f and n, we have two equations. Simultaneously solving these equations gives us that F is equal to 5.07 kilonewtons and N is equal to 2.74 kilonewtons. And that's our final answer.